Alright, so we are going to start off with a percent problem here. This is a mixture problem again. So again, with all mixture problems, we're taking one thing plus another thing, and we have to use the blank plus blankety blank equals blankety blank 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 formula. Alright, so let's leave room for a let statement, and then let's have our blanks filled out. Okay, so we're talking about two types of metal. That's what an alloy is. And it says how much. What does how mean again? How much? That tells us our variable. Okay, so let's underline that right now. We'll come back to it. How much of an alloy that is 20% copper, so a metal that's 20% right there, should be mixed with 200 ounces of another alloy, so that's this is number 1, this is number 2, that is 50% copper, in order to get an alloy that is a 30% copper. So that's our goal. So we have a 20% and we have a 50%, and we have to smash them together, kind of melt them down, and get 30%. Okay, so let's talk about what our let statement is going to be. Let x equal what? How much? Amount of what?
X equals 20% copper.
Good, and we're going to put amount. And it is, I see the word over here, it says ounces. So I'm going to write ounces of 20%. Okay, so let's fill out our blanks. Remember, it's going to be number 1 plus number 2 alloy equals our goal, right? Okay, so in number 1 right here, our percentage is how much?
20%.
Good, and we're just going to use 20. And our amount is the X. Okay, and our number 2, our percentage is 50%. And our amount is how many ounces? 200. Our goal, what is our percentage for our goal?
30%.
30%, good. Now we have to be careful with our amount, right? We have X amount and we have 200 ounces. So what's the total right there?
200x.
200
plus x.
Plus x. Very good. And can you say x plus 200? Absolutely. All right, now we've got a regular equation. So let's keep going. Same mixture problem type. So it says how much water should be added to a solution that is 70% antifreeze in order to get 35 gallons of 60% antifreeze. Do you know what antifreeze is?
Mm-hmm. You put it in so that when it sprays on the windshield, it keeps it from frosting over so that you can't see.
Exactly. So it's interesting here. They're asking how much water should be added to 70% to get it down to 60%. So we're watering it down, right? Okay, do you see the keywords in there? How much water? What does that tell to us?
It tells us that water is a variable.
Water is the variable. Okay. So let x equal amount of water. And what is the unit?
70%.
What's the unit of water? How much water?
Gallons.
Gallons, good. Okay, let's do our blankety blank formula. Okay, so this one's going to be the water. This one's going to be the antifreeze. And this is going to be our goal again. So, let's talk about how much antifreeze is in water. Just regular water. My water gallon right here. How much antifreeze is in there?
0.
0. Hopefully none, right?
Yep.
Yeah, definitely hopefully none. So what's the percentage in the water?
0.
0%. So 0 times X amount plus, what's the antifreeze we have on hand? What percentage?
70%.
70%. Now it doesn't quite say the amount, so let's come back to it. All right. And our goal is to get what percentage?
60%.
60%? And how many gallons?
35.
Excellent. Now, we want a total of 35 gallons. We want X amount in this one. How much do we want in this one? Let me suppose to you. We want 35. What if I told you X was 10? How much would be left for here? How'd you get that?
35 minus 10.
Good. So instead of 10, we're going to do 35 minus
X.
X. Excellent. So that happens anytime they give you the total goal weight is you're going to do X amount for one, and it has to be total minus the X for the amount of the antifreeze. It always has to be the total amount, right? Because if we flip it around, we're going to get a negative number.
We're going to need the distance triangle.
You are sure right. So we are talking about distance now. Alright, so let's go ahead and draw that distance triangle that you were talking about again. So we're talking about a jet plane traveling at 500 miles per hour overtakes a propeller plane traveling at 200 miles per hour that had a 2-hour head start. How far? Can you circle far? That means distance. If they ask how long, that means time. So there's a difference. How far is distance? How long is time? From the starting part of the planes. Alright, so Mr. Anderson, this is a key thing on this one. You have one, both planes start from this point, same airport. Here's the propeller plane going, just 200 miles per hour. And then we have a jet plane starting again, going the same, and he overtakes. So when he overtakes, he's going to pass it, right? So there's a jet plane, and he's going 500 miles per hour. So here's the question. When they pass each other, they have gone not the same rate, and definitely not the same amount of time, but they've gone the same what? Distance. So I want you to underline overtakes. Anytime you see the word overtakes, this is a same distance problem.
What would be the terms to find the rate? Like what would they say if they wanted you to find the rate?
Find the speeds. Yeah, that's good. Good question. So anytime it's the same distance problem, though, it's not going to be a blank plus a blankety blank equals a blankety blank blank blank. That's going to be a mixture of one distance and another distance equals a total distance, just like we mixed two things together, right? So same distance is going to set equal to each other. So that's going to be the jet's distance and the propeller distance. Justice Department and Police Department, right?
Oh, yeah.
Alright, so let's talk about distance. To make distance, we go up to our triangle and we cover D up. So distance is what times what?
Rate times time.
Rate times time. Now we know the rate of each of them. Do we know the time?
2 hours.
Well, this one, the propeller plane had a 2-hour head start, right? So he has 2 hours less or more.
2 hours more.
Okay, so he has 2 hours more than the jet plane. So, do you notice I said jet plane last? He gets the variable. Let x equal time of jet. And how do we say 2 hours more? than this. He had 2 hours more than X.
X plus 2. Or X, yeah.
Okay, so we're going to take rate times time. So here we go. Rate of the
Sarah
jet
Heathershaw, please come to the front office to leave, please. Sarah Heathershaw,
is
to the
500.
front office to leave, please.
And his time is X. Okay, what's the rate of the propeller?
200 miles per hour.
Uh-huh. And what is his time?
X plus 2.
Excellent. Now we've got a regular equation, right? Distribute, distribute. Subtract over 200x. And we get how many x?
300x.
Divide by 300. We get x equals 4/3. Now, that's 4/3 of an hour. But is that what our final question was asking from us?
No.
It was asking for distance, right?
So now we have to use the time we found and do rate times time.
Right. So maybe let's do 500 times x, right? Or we could do 200 times 4/3 plus 2, right? But we can, both of them should come out to be the same. So 500 distance equals 500 times x, which is 500 times 4/3. Which is 2,000 thirds. But we would never say 2,000 thirds miles, right?
Nope.
We'd probably say like 666.7 miles would be more likely. So, the planes are 666.7 miles from the starting point.